Good day, everyone, and welcome to Business Statistics, FIN 3153. I am Professor Fatme, a faculty member of the Finance Department under the School of Business and Governance of Ateneo de Davao University. In this lesson, we will discuss Module 1, Introduction to Business Statistics. We will learn what statistics is, why it matters in business, and how data can help managers and organizations make better decisions. For your pre-class task, recall one real-life situation where data was used, such as scores, surveys, ratings, or sales reports. Briefly explain what information was shown and why it was useful. After class, answer and submit the end-of-module questions before the deadline. Please also spend at least 3 hours reviewing the lesson and write a short reflection on how statistics helps in business decision-making. This slide presents the student learning outcomes for Module 1. By the end of this lesson, you should be able to distinguish between descriptive and inferential statistics. You should also be able to differentiate quantitative variables from qualitative variables. Lastly, you should be able to identify the 4 measurement scales used in data analysis. Statistics is the process of turning numbers into useful information. In business, numbers are everywhere: sales, expenses, customer ratings, survey results, and employee performance. But numbers alone do not always tell us what to do. Statistics helps us organize, analyze, and understand these numbers so we can make better decisions. Let us start with a simple example. Suppose you want to eat a great steak tonight. What will you probably do? Most likely, you'll check Google, look at the ratings, read some reviews, and compare restaurants. This is already statistics in action. You are using numbers and information to make a decision. Now, we can see different customer reviews with different star ratings. Some reviews give 5 stars, while others give lower ratings. But the question is, which review is more reliable? In statistics, we do not rely on only one opinion. We look at the number of reviews, the average rating, and the pattern of responses. This helps us make a more informed decision, instead of depending on one single comment. Here, the review summary gives us a clearer picture. Instead of depending on one comment only, we can look at the overall rating. This restaurant has a rating of 4.6 based on 444 reviews. Because many people gave their feedback, the rating becomes more reliable. It is less likely to happen by chance, compared to a rating based on only a few reviews. In short, statistics helps us make sense of numbers so we can analyze and understand the world around us. Let us take another simple example. Many of us like ice cream, but imagine that you own an ice cream shop. How will you decide what flavors to sell? Most likely, you will ask customers what flavors they prefer, count their answers, and use that information to decide. That is statistics again, using data to make better business decisions. The survey asked 100 adults about their favorite ice cream flavor. Chocolate received the highest number of responses, with 17. Vanilla followed closely, with 15 responses. For an ice cream shop, this suggests that chocolate and vanilla may be the safest flavors to offer first. This chart gives another evidence of customer preference. In this larger survey, vanilla and chocolate are still among the most liked and most preferred ice cream flavors. So, if many customers already prefer these flavors, businesses may choose them as safe options. That may be why many fast food restaurants commonly offer vanilla ice cream, with chocolate as a topping or flavor option. Now that we have seen simple, everyday examples, let us move closer to business. In business, statistics is used to understand customers, compare performance, study sales trends, measure satisfaction, and support decision-making. So, in the next examples, we will see how statistics works in real business situations. Suppose you are launching a new product and you offer sale or reduce its price to attract more customers. Before the price reduction, the average purchase amount was $50. After the price reduction, it increased to $55. At first, this looks like a good result. But we need to ask, is the $5 increase really because of the price reduction, or is it just random variation? Statistics helps us answer this question by checking whether the price reduction had a real impact on customer spending. Suppose you run a cafe and launch a new menu item. You post this new item on your cafe's Facebook page, and customers start reacting, commenting, sharing, and mentioning your cafe online. Before the launch, the cafe had an average of 50 Facebook mentions per day. After the launch, the average increased to 150 mentions per day. Now the question is, can this increase in Facebook mentions help predict more cafe visits? Statistics can help us check whether online engagement is connected to actual customer visits and whether social media activity can help forecast sales trends. In business, statistics helps managers understand what is happening behind the numbers. It helps to summarize business data, to draw conclusions from those data, to make reliable forecasts about business activities, to improve business processes. For example, if sales drop after the Christmas season, a department store may study its sales data and notice that fewer customers are buying in January. To attract customers again, the store may offer discounts or clearance sales. This is why many businesses use statistics to summarize data, draw conclusions, forecast what may happen next, and improve their decisions. There are two main types of statistics: descriptive and inferential. Descriptive statistics is used to organize and summarize data that we already have. For example, a bakery may look at its daily sales and find that the average daily sale is $89. This helps the owner understand past performance. Inferential statistics goes one step further. It uses a smaller sample to make guesses or predictions about a larger group. For example, the bakery may ask some customers what type of bread they prefer. Based on their answers, the bakery can predict which breads most customers may want to buy. So, descriptive statistics summarizes what happened, while inferential statistics helps predict what may happen next. Both are useful because they help businesses understand past performance and make better decisions for the future. Now, let us move to the next section, the basic vocabulary of statistics. Before we go deeper into formulas and analysis, we first need to understand some important terms. These terms will help us describe data correctly and understand the next topics more easily. A variable is something we measure or track to understand a situation. In business, sales can be a variable because sales can change from day to day, week to week, or month to month. For example, if sales increase after a promotion, we can track that change and study what may have caused it. So, a variable is anything that can change and can be measured. Now we connect two important terms, variable and data. The variable is what we want to measure or track. In this example, the variable is sales. When we record the sales numbers every day or every month, those recorded values become data. So, the variable tells us what we are studying, while the data gives us the actual numbers we will analyze. An operational definition explains exactly how a variable will be measured. For example, if our variable is sales, we need to be clear about what we mean by sales. Are we measuring daily sales, weekly sales, or monthly sales? In this example, monthly sales means the total revenue from sales in one calendar month. This makes the variable clear and measurable. Yearly sales means the total revenue earned from sales in one full year. For example, instead of looking at sales day by day or month by month, the business adds all sales from January to December. This helps the business see its overall performance for the year and compare it with previous years. Another example of operational definition is the difference between sex and gender. If a study uses the variable sex, it usually refers to biological characteristics such as anatomy, physiology, genetics, and hormones. In many surveys, this may be measured using categories such as female and male. But if a study uses the variable gender, it may refer to social, cultural, and psychological roles or identities. This can include categories such as female, male, non-binary, genderqueer, and others. So, the operational definition is important because it tells us exactly what we are measuring and what response options will be used in the study. The next important terms are population and sample. A population is the whole group we are interested in studying. For example, if a business wants to understand its customers, then all customers are the population. A sample is a smaller group selected from that population. Instead of asking every customer, The business may ask only some customers and use their answers to understand the larger group. After population and sample, the next terms are parameter and statistic. A parameter describes a characteristic of the entire population. For example, if we know the average satisfaction level of all customers, that is a parameter. A statistic describes a characteristic of the sample. For example, if we ask only some customers and get their average satisfaction level, that is a statistic. So, parameter is for the whole population, while statistic is for the sample. When defining a variable, the first step is to identify the characteristic we want to study. A characteristic is something about a person, customer, product, or situation that can vary. For example, we may study a person's age, because people can have different ages. We may also study sex, because respondents may belong to different categories. So, before collecting data, we must first ask, what specific characteristic do we want to measure? After identifying the characteristic, the next step is to assign an operational definition. This means we clearly explain how the variable will be measured. For example, age can be defined as the number of years a person has lived. Sex can be defined based on biological characteristics such as anatomy, physiology, genetics, and hormones. By giving an operational definition, we avoid confusion and make sure the data can be collected consistently. The third step is to establish the type of values the variable will have. Some variables are quantitative. This means their values are numbers that can be measured or counted. For example, age is quantitative because we can record it as a number of years. Other variables are qualitative. This means their values describe categories or qualities. For example, sex is qualitative because it is recorded using categories such as female or male. So, after defining a variable, we must also know whether the data will be numerical or categorical.